researchers, students, ladies and gentlemen. Welcome to the annual international seminar organized by Faculty of Fisheries. My name is Thanat Pong Pokawanit. I'm a lecturer from the Department of Marine Science, Faculty of Fisheries. I will be your MC today, this afternoon. It's our pleasure to once again present the annual international conference as the Faculty of Fisheries. This seminar is held annually as part of the University Academic Conference, bringing together researchers from our faculty and international collaborator, includes experts from China, Indonesia, Japan, Korea, Malaysia, UK, and USA within the last few years. Last year, our discussion was focused on the fishery and carbon neutrality. This afternoon, the seminar is the second session of the research activity hosted today by our faculty. Earlier this morning, in this very room, we had an engaging discussion between Thai business sector representative and researcher from our faculty. Building up from this morning discussion, this afternoon we will focus more on the research aspect of the artificial intelligence and the fisheries, a rapidly evolving technology that has transformed numerous fields and points to drive even greater changes in the future. The theme of today's seminar is AI and Fisheries, Research, Frontier, and Technology. We have 5 insightful presentations from researchers based in China, Japan, and Thailand. Each presentation will last approximately 15 to 20 minutes, and we will welcome the question after the presentation, each presentation finish. Without further ado, let's begin. I'm honored now to invite Dr. Rungparit Chongcharansuk to share the seminar. Please sit here. Thank you. Okay. I will also be a co-chair of this seminar.
So, afternoon, everyone. My name is Rungparit Chongcharansuk. I'm a lecturer at Department of Aquaculture, Faculty of Fishery, Kazakhstan, University, Thailand. So today I very, very appreciate to be a co-MC for afternoon session. So the afternoon session, actually, we have the 4 interesting presentation by the 4 persons. But firstly, I would like to introduce Associate Professor Dr. Vala Chepahudi from the Department of Aquaculture, Faculty of Fishery, that the topic is AI in actions, breakthrough application for fishery and aquaculture. Please, Dr. Vala, please.
Okay, good afternoon again. We meet together again in the morning. I was an MC and now I'm speaker. 2 positions at the same time. Okay. Let me check the pointer, please. Where the pointer? ขยายได้ไหม? Okay. It's my honor to speak about the AI applications in fishery and aquaculture, right? With the rapid advancements of AI technology, its adoption has expanded across various industries, including fishery and aquaculture. Today, I will talk in 3 topics. First, just introduction. What is AI? What the AI can do? How AI works? What AI can do in fishery and aquaculture? The second example of use in fishery and aquaculture. And the final topic is just summation. And I will try to finish my speaking within 20 minutes. What is AI? AI is artificial intelligence. Is referred to machine-based processes. It mimics human cognitive functions. It can reduce human workload. It can improve accuracy and minimize making decision errors. Sorry. Sorry. You can see from this image. Artificial intelligence consists of machine learning, neural network, and deep learning. Machine learning is subset inside the artificial intelligence or AI. Neural network also is subset in machine learning. And the deep learning is subset in neural network. Actually, the deep learning is the advanced technique in the neural network. It's nearly human brain process. What the AI can do? First, learning. It is acquiring information and rule to do it, such as machine learning. Second, listening. This choosing the logic to solve the problems and makes conclusions. The third, perception. This interpreting data from the environment, such as image, text, or sounds. The final decision making, it choose action to achieve some specific goals. How AI work? This figure show from the data collection, data pre-processing, feature engineering, model development, model evaluation, model optimization, deployment, and then making and maintenance. This is a cycle, and the data pre-processing take the longest time in this process. I just show you the example code workflow of the AI. You can see start from the important library data. It depends on your works. Second, the load data sets, followed by the data processing, and then we can split data into training, validation, and testing data. And then we try to build model. In this stage, you can choose any model if you want. Then when you choose it, we train the model, evaluate model, and then we can show the result and print the result and visualize the data, such as table, confusion metric, or anything else. Then we can save the model, and the model you save can do the AI in the future. What the AI can do in fishery and aquaculture, I just show you an example what to do. Monitoring water quality, automating feeding system, detecting fish disease through image recognition, optimizing harvest and supply chain logistics, price forecasting, image classification, weight estimation, and etc. Example project. I will show you some project conducted by my team and me about AI. In 3 topics. The first topic is about image classification. The second, water quality prediction. And the third is weight estimation. First project, sorry. We focusing on the image classification because you see if you know about Lacerator brachysoma or short mackerel and Lacerator canagata Indian mackerel, it shares similar external experience, and difficult to classify by normal people requiring expert. Lucky, in this project, Professor Sommai helped us to classify these two species, and we try to classify these two species, and by using image capture from the smartphone camera, and then using transfer learning model to classify them. This, okay, you can see from the slide left and right hand side, similar, very similar. It's difficult to classify, but the in Thailand, the short mackerel is significantly economically species in Thailand. So we start the study. We start from the capture camera cap image from the smartphone camera, 267 from the short mackerel and 250 for the Indian mackerel, and then we randomly separate into three folders: training, validation, and testing purpose. The ratio is 7:2:1. But finally, when we separate like this, the training data may be limited. So we have the augmentation technique, such as zooming, rotation, flipping, and zooming to increase the number of images. Finally, we get almost 10,000 images to do for the training purpose. Then we use transfer learning technique. 6 models we use. Why we choose these 6 models? Because from the previous study, all the 6 models showed the good result for image classification. So that's why we choose all these 6 models. This transfer learning technique model have pre-trained with large data set before, and let's the user to fine-tune the model for the specific work or your work. This just show you the architecture of each model. It's very complicated. This the flow chart from the input image to data preparation, deep learning model, evaluation, and then show the output. The results show that the exception model show the good performance in training and validation, almost nearly 0.8 accuracy during training and validation, and loss very low. This we try to compare the result between other model. It's still exception model show the best result. Accuracy is 0.757, better than others. After that, we try to fine-tune the model using the number of apex. And finally, we found that 30 apex is optimal performance. You can see get almost all more than 0.8 accuracy, precision, recall, and F1 score. This is a performance for data mining. This graph also show clearly 30 apex show the best result. The darker color blocks more accurate than the lighter blocks, and you can see it shows that it can predict or classify these 2 species. The conclusion for this study, exception model at 30 apex show the best result compared to the other 5 models. The second project, we try to compare water quality prediction for the red tilapia culture in outdoor RAS using deep learning and a hybrid model. In general, to maintain water quality in aquaculture system also in the last system is really crucial and can affect the fish production. If we know before, we can arrange good or manage well in that condition. But the challenge arise due to the instrumentation limitation and delay in laboratory measurements. So this we try to use this model to predict important water quality for aquaculture. This is the farm layout. The darker or blue color block shows the grow out ponds, and the gray or lighter color shows the nursing pond, and T1, T2 is the treatmentation pond. That's why this last system in outdoor. This farm management is liner ponds and using automatic feeder and applies water pattern view aerators. We try to predict the important water quality for the fish culture, such as DO, pH, tan, nitrite, and alkali. But if we use all these parameters to predict, it maybe take long time and computational cost and process or time. So we use a random forest model to choose the most three influential features to predict the water quality. Model we use a convolutional neural network or CNN. We use long short-term memory or LSTM, and finally we try to use a hybrid model between CNN and LSTM. And then we try to compare between the number of apex is different. Start from 10,000, 3,000, and 5,000 apex. This graph shows the important feature parameter that can predict that water quality. So that's why we can choose the top three to predict the model. And this is the result. You can see from the left-hand side, it shows compare between actual and the data from the model. You see, it's parallelly. And the right-hand side is linear regression. Show, okay, they can predict really well. The OPS. Tan, nitrite, alkali. Okay. For the conclusion, the hybrid model between CNN and LSTM at 5,000 apex show the good result for RMSEE, MAE, NIMSEE, and R square. For predicts the DO, tan, nitrite, and alkali with high accuracy, except PS. It's maybe because PS is depend on other parameter than this. Yeah. Next slide. The final example project is we try to use a deep learning model to do weight estimation of red tilapia in cage culture using the image captured from the drone or UAV. In general, to weight estimate in fish is labor intensive and maybe cause the fish stress. So if we try to use these, okay, maybe save the time and the fish is be healthy. From the 400 cages, we select only 8 cages to study. And we release the average weight of fish at start at 50 grams, and we at 1,500 fish per cage. We culture for 5 months. The fish grow from 50 grams to 900 grams. UAV we use DJI Air 2S Mavic, and the elevation above the water surface was 3.5 meters Why we choose this elevation? Because we proved before. In this elevation, not disturb fit behavior and can catch the image very clear. And okay, we in each case we took photo 50 images for each case, and we do the 9 flight. So totally we got the image 3,600 image for this study. Before the image processing, we crop each image to a size 2 by 2 meter to reduce the size of the image. And we separate the image into 9 folders according to the weight, average weight, start from 100 gram to 900 gram. This the UAV we apply in this study. And this also the example of image of each cases in each class is different weight, average weight. So actually it's difficult to see, even to see by our cell eyes, difficult. And you see after cropping 2 by 2 meter from the left hand side to the right hand side, we use the right hand side image to do prediction or analysis. Sorry. Back please. And next slide, please. Okay, the same for the confusion metric heat map. The darker color block is more accuracy than the lighter block. This show that on the right hand side on the image C, number C, is a hybrid model between CNN and XGBoost at 45 apex and 45 S meter show the best result in this study. This also show the percent accuracy of each model. The conclusion show that we can use UAV to evaluate the weight estimation of the fish. And the hybrid model show the best result, show the accuracy almost nearly 0.8 for weight estimation. In summary, I just show you the example of AI application in aquaculture and fisheries. It is really useful, you can say, and can be applied to many fields. However, in my opinion, I think the development of AI technology in Thailand is very slow, and very few people can understand it. However, the most important aspect is data collection. If you can collect the accurate and sufficient data, it can enhance the effectiveness of AI. As the saying goes, data is the new oil. So before you start using AI, you choose first understand how to collect data. Thank you for your attention.
Wow, thank you very much for your excellent talk. It is quite knowledgeable. So I think it's time for question. Is there any question from the floor? Or also from the audience online? Please let us know if you have question.
So I have questions. So the question is, was very interesting, but my question is about what I think that AI should go in the future research. And can you suggest about the researchers or students if we would like to go to use AI, what the thing or what is the topic should be in the future?
Okay, thank you, Dr. Thongpalit. if someone want to study about AI, as I told you before, the data collection is very important. The data collection, and maybe someone asks me, how about the data? How many data enough? It cannot say what the enough or not. It depends on the performance. You can see from the performance such as accuracy. Is you also accept for the accuracy or not? If no, you can improve your model or collect more data. The other thing is for the fishery student, you may be afraid about coding. It's not a problem. If you know the background or basic of machine learning, deep learning, finally, in present day, you know, many AI such as ChatGPT, Claude, Gemini can create the code for you very easily. But you should understand, and whenever you can understand the code, you can change the code as you want. So don't afraid about AI. You have to try. Thank you.
Thank you very much. Any question from the audience or in this room or in the online audience? So the next question is, what's about the image analysis that some of your research is using a drone to take an aerial image. How about the underwater camera? Is that possible for using it?
Okay. That's the big point or big problem for image classification or image analysis. Turbidity or sun glare. We faced this problem before. This can disturb your quality of the image, quite sure. But for this study, I did not tell you about when we take the image. We took the image in the morning, early the first feeding. Why? Because the fish did not eat the food for almost 12 hours from the afternoon until morning. Really long time. So they hungry and then they are swimming near the water surface. That's why we choose this time to take the photo. Okay. Any questions?
So just a little bit announcement. So for the audience online, you may turn on your microphone and ask for a question or raise your hand so that we can communicate your question to the presenter. Or if you like, you can type your question. We can read it out to the presenter. I think we still have time for one or two more questions.
Or maybe for Thai student, you can ask in Thai. Okay.
Yes มีภาษาไทยมีข้อคำถามอาจารย์ไหมครับภาษาไทยผมแปลเป็นภาษาอังกฤษให้
ครับ
สามารถถามเป็นภาษาไทยก็ได้นะครับ
ครับ
ผู้เข้าร่วมฟังออนไลน์ครับอยากจะแปลเป็นภาษาอังกฤษให้
Can you understand my presentation?
Yeah, อาจารย์ครับ I have a question. I don't know whether this is the question too big or not, but I can see you. I think from this morning and also in your presentation, you said that the data is very important. The barrier for the AI to further develop is not the AI itself.
Yes,
Input
sure.
data.
Sure. Yes, that's the big point.
Okay, so I think, and also you mentioned about Thai, we are a little bit slow in this field. So my question, there are two questions. First question is, what is our position? I mean, as a Thai researcher compared to the AI in the fishery outside Thailand? That's the first question. The second question, what should be the next step if we want to, bring us in the better position in the world? Thank you.
The first question for the knowledge of AI, if compared to other countries, I think is not far. is equal. I can say is really equal in the field of aquaculture or fishery. I don't compare to the engineering or computer side. It's far beyond us. We accept this. So the second question, right? How to do, right? I can tell you that of my work, I start from the small data because we cannot get the big data right now. So we try to collect many data and we can improve the model and more and can obtain accuracies more and more. That's the way we can do. Or the other thing is we try to teach the student to improve themselves to understand about the AI or new technology, and involve them to do about this subject. Maybe is a good way.
Okay, I understand that now we need a good data collector. The student at least they have to know how to collect quality data and also how to record and how to report the data. So it will help us push toward the good AI future for Thailand fisheries. Is there any other question? Okay, I think without question, maybe we can finish the first round.
Yes, we can finish. Or maybe I have a final questions for the researcher. If some researcher would like to start with AI today, what the thing you recommend to ask how we can start learnings about AI? What the thing we should do to learning about AI for example, after this class, I come back to my house and okay, I would like to learn AI. What the thing I should start?
From now on, actually, is knowledge is in the air. Everybody can study by themselves from the internet, right? Whenever you want to study, okay, you go to the Google and you can search. Okay, you can do some clip or learn some clip from YouTube. It depends on you, right? But whenever you don't understand, you can ask some expert to explain some points. No need to learn or no need to attend in the class and take for a long time for study. You can learn by yourself, actually.
Right. I think thank you very much, Professor Vara, for your great presentation and sharing. Thank you.
Okay, thank you.
Okay, for the second presentation, let me introduce Assistant Professor Dr. Sukrit Nimitgun. He is actually a lecturer from the Faculty of Fishery, Department of Agriculture. Please welcome.
Okay. Good afternoon, everybody. My name, as you already know from my slide, my name is Sukrit Nimitgun from the Department of Aquaculture, Faculty of Fisheries. So this afternoon, I would be happy to talk about the subject of my research, autonomous molting detection systems for commercial soft-shell crab production. I have almost 60 slides, but I assure you I will go through it very quickly. I want to be on time. My students keep complaining that I always go over time. So what is molting? Molting is when the crustaceans, such as lobster and crabs, want to grow. They cannot expand their exoskeleton like human because they don't have a flexible skin. So they have to get rid of the old exoskeleton and then make a new one, a bigger one. So the process is called molting. And this is the video of that molting process. So basically this crab, they want to grow, but they cannot expand their shells. So the only way possible is to get rid of the old one and then make a new one that's bigger. This is how they do it. They come out from the back, and while they're doing it, they absorb a lot of water. That's why the skin expands, by dumping a lot of water into the body, like this video. And this is the most valuable time in their life because they are defenseless. They can get killed, they can get eaten by the predator. Well, the talk today is the crab die during this process. We want to make the soft shell crab anyway. So the crab that came out, very soft, and that's when humans want to collect them and eat them because we want to eat them, but we are so lazy that we won't want to get rid of the shells. Okay, so basically, this is another still picture of the process. So now everybody know about the molting already. So people harvest soft shell crab to make the food a long time ago, not only in Asia, but also in US, Southeast Asia, East Asia. It seems to be very favorite to a lot of people. So, however, this is how we do the soft shell crab right now. We put each crab into the box, and then we're looking at the box every 4 hours, every day, 7 days a week, 24 hours a day. So it's very difficult and really labor intensive how to do it. And if you look at it, can you spot any soft shell crab? It's highly skilled worker. Imagine you have to do this at 2 a.m. in the morning. I would not be happy. Okay, and she found one actually. Look at it, and I'm not even noticed any crab, let alone the soft shell crab. See? So, and this is a typical soft shell crab farm in Thailand. So imagine the labor and the effort that need to go through. And this is an example of the soft shell crab. The new crab is a bigger, cleaner one. Okay. Right now, we use this genus, Scylla, mud crab, to do the soft shell crab industry in Thailand. I would say 99.99% of the crab that being produced for the soft shell crab came from this species. However, we would love to do the soft shell crab from this species, which is a blue crab, which is a common species we have in Thailand, right? This species, we can culture them from the eggs into the young crab. We can also have a really good meat quality and a really fast growth rate. About 4 months, they can reach adult from the eggs if the condition is right. However, remember that 4 hours that you have to check. This crab, you need to check every 1 hour. Life cannot be perfect. When something good, something always bad. So if you want to make the soft shell crab from this species, every 1 hour. Who want to work with me? No one, right? So my employee or my coworker will look like this, and we don't want that. So I showed this picture to Professor Vara 10 years ago. I have to speak of him, very highly of him. I just came back from my PhD. I just finished PhD, and I start working here. Our office is next to each other. So I talked to him a lot, and he's the one who taught me when I was a student. So when I show him about the problems of the soft shell crab industry and things like that, and I show him that when I was a student, grad student, I used to buy the night vision goggle to go to catch my own crabs for the experiment when I was still a PhD student. And Dr. Vara came up with the idea that, wait a minute, if the night vision goggle can see the crab so clearly because of infrared, we can do something about it. And that is when it started. So after lazy for a few years, I finally got the funding, the grant, to do the detection system. We did not use the AI because AI is too complicated for us for this task. We use image processing, okay, which is kind of like less than complicated than AI. So basically, the idea is we can use the CCTV camera, take a picture of the crab, and then when it's molt, it becomes 2 crabs per box instead of 1. That's it. Easy. And then the system can tell us which box has already molt. So we can have the data, we can have the accuracy, and we can have the freshness of the crab molting. So we first start at one of our research stations, belong to the Faculty of Fishery here at Klong Wan Fishery Research Station in Prachuap Khiri Khan Province. And then we get the funding to buy like cheap CCTV camera, just normal computer, and a pond, a cement pond. That's it. And then before we put the crab in each box, we have to make sure that the crab is about to molt. And how can you know that which crab is about to molt, which crab is not molting? Well, we have a few places that you can look at it. I will not go into the detail, but you can look at the abdomen like that. If they have a black band like that, it's might molting. The second one is if you break the shells and you see the new shells underneath, that's kind of good indication that it's going to be molting, okay? And the last, we can look at the swimming legs. And this is the picture of not molting and molting. Makes sense. The one that about to molt have the new set of shells underneath it. So you see it as a 2 line, right? The one that did not gonna molt only have 1 line. Makes sense. You have 2 shirts underneath you or you have 1 shirt underneath you. Okay? Anyway, this is kind of user interface that we think about it. Wait a minute, before we go ahead, I would like to emphasize on this. I don't care if it's AI or normal research or implication or whatever research. You need people. You need money. It comes from anywhere, a funding agency or even your own money. I don't care if you have enough. And we have technologies. And finally, everybody needs the right attitude. If you have a right team, everything is possible. If you have a wrong team, even walking is impossible, right? So we think we had the right team. I will go further. I will go a little bit more detail in that. After that, this is how we do it. We use the image processing technique, which, by the way, we collaborated with the Faculty of Engineering at Kasetsart University. So this is a normal, what the camera see is the upper picture, and what the program see is the lower picture. It's only see black and white. We only need that. And the way we do it, we count the percentage of the white pixel against the entire box. The idea is, if the crab molting, we're gonna have more white pixel than before. So if you look at it, the one that not molting, the area fluctuated between 22, 25, 20%, 22, 23%. Why change? Position of the crab change. The white pixel change, but not much, right? After 10 minutes, the area is about 20, 25%. Wow, not molting. The one that molt, because they have another crab coming out from the old one, they have more area. So when they have more area, the white pixel area almost double. See, from 15% to 29%. And that's how the program detect molting. It's much easier than what your iPhone can do right now. Like your iPhone can detect your face automatically. We don't have to go to that complication. Anyway, we found that the one that molting show the symptoms after about 5 minutes. So we can detect the crab molting only 5 to 6 minutes after they start molting. And that makes sure that we can collect the crab before the shell become hardening in 1 hour. Okay. So this is the example of our program. This is a video. Every 10 seconds interval. The green means not molting. The one that about to molt, I think is C5 or something. You will not see it right now, but it's gonna turn to yellow and red. See, the one that already molt. So in that case, you save the time for your labor. So your people doesn't have to go through 1,000 and 1,000 of crabs. He still cannot sleep at night anyway, but at least he don't have to go through 1,000 and 1,000 of crabs. So he can go directly to the one that molt and save his energy. So this is the graph that I would like to show that we have to sacrifice a little bit on detail, on technical detail. The more accuracy you want, like say the hit rate, the higher hit rate you want, the lower precision you're gonna get. Which means that if you want to collect every crab that molt, you might have to deal with a lot of false alarms because the system is still not perfect. Sometimes they have a false alarms. The crab doesn't molt, but the system show you that it's molt. If you want to have less false alarm, you have to set the threshold very high. And that means you might miss the one that actually molt. So we're struggling with that right now. Anyway, after this, we published the paper about these detection systems. And again, I would like to express my sincere gratitude to Professor Vara on this. So, however, I didn't stop with that. We tried to make it into the outside research, which is the business. So we actually get the funding from the NIA, National Innovation Agency, I think. So we get the funding from the NIA to try to make it into the real business. And we got the place to do it in the southern Thailand. And we try to make it more than just what we try in the research, installing the camera. Now we don't use the CCTV camera anymore. We use the specialized camera. And we put the crab in the box like that so the camera can see. We control the temperature. We control the water quality. We actually have really easy access to the fishermen. Okay. And when it molt, it looked like that. And we actually designed the new interface to make sure that we can see the molting crab even more. And the new program is like this. It's based on the old program, but now you can see the crab more clearly. The one in the middle, on the second one on the left, is about to molt. You probably see it right now. So when the area is become more and more, it passed through the threshold, and then it detects as a molting. On the left, come on. I don't know why it stopped. It's turned yellow and red. Okay, good. And it documents the timing, and we can keep collecting data if we do this, okay? I hope that my Japanese and my English, my Chinese is correct. It should translate into delicious. Am I correct? Okay, good. I'm relieved. Yeah. Sometimes this thing can backfire, you know. Yeah. Okay, and this is how I show you that the soft shell crab from this species is far more superior from the mud crab species. The meat is more, the look is prettier, and the taste is much better. Oh, well, you cannot believe me. I'm biased on this. Yeah, I think the mud crab, soft shell crab from mud crab is not that good comparing to the soft shell crab from the blue swimming crab. You see the meat, right? Anyway, we go all the way to try with the actual restaurant, and this is the result. Even the meat of the soft shell crab, I know we do the soft shell crab because we don't want to deal with the shells, but once you have the soft shell crab and you can peel the shells, even though it's soft, you still can peel it. And the meat texture is different from the crab that have a hard shell. So it's really difficult to do this, but the meat quality is well worth it. Okay, that I do a good timing, I guess. Okay, thank you very much. And right now, we are much more than this. We develop into something new in particular, but I cannot say much about that right now. But we never stop working on this. This is about 2 years ago, but right now we have something on the pipeline. But we keep producing more and more and more, and we keep develop more technique to be able to produce soft shell crab from this species. Our aim is to produce at least 100 tons per year, at least 100 tons per year. But that's really far, far away dream. But we working on it. Keep walking, even though it's slow, but we hope that we walk in the right direction right now. Okay, thank you very much. Thank you very much. Thank you. And I will be happy to take any questions. Yeah.
So thank you very much. This was very interesting from the Dr. Sukrit. So do any of you have any questions from in this room or the online sessions?
Or maybe. Thank you.
Do you have any
Yes.
questions?
Some fan page that said in Thailand is ขอบคุณอาจารย์สุกฤตสำหรับข้อมูลใหม่ค่ะ She said that.
Okay, thank you. Another.
ใช่อันนี้ใช่เหมือนกัน There is one question from Miss from the audience Naguroho. Thanks for your valuable insight, Ajahn. I'm sorry if I missed some of the information you explained. Is it possible to build a device predicting water quality in a lake, such as upwelling, rising of sulfur from the bottom of the lake? Please suggest on how we should prepare the device.
Well, it's pretty far away from the soft shell crab, isn't it? I probably not the person who qualified to answer that. I'm so sorry.
Okay.
But well, if I have to guess, yeah, why not? I think it's doable if you ask me. But I'm probably not the best person to answer that. Sorry.
น่าเป็นคำถามต่อเวลา Okay. So there are also another question, but I think all of this question I will keep it at the end. So I guess every presenter can help answering some of the a little bit general question. Thank you. Is there any other question from the floor?
So about the AI soft shell production.
Yeah.
What the topic of the AI that should go further?
Okay. Yep.
For this culture.
Well, during our adventure on this project, we try to work with the AI engineer, the private company, to not only use the image processing technique, but using the AI to do the same thing. The trick is like Dr. Vara said, the data is the most important things. And I have no doubt that AI can do the same thing with more efficiency, because what we require to do this is not that hard. We require to separate something from 1 to 2. That's it. I think AI can do a lot more than that. So if you want to develop AI to do this, I think it's doable. And further than that, it might can detect the crab movement. This is what I like. Before the crab gonna molt, they will stop moving because they're about to molt. They're about to go shed the old exoskeleton. So they will stop moving. If the AI have enough data, they might be able to warn us before the actual molting even occur by looking at the patterns of the movement of each crabs. And also we have a lot of dates of the crab inside our systems. And anybody have really experience with the dead crabs? It's not fun. The smell is pretty bad and it make the water quality go bad very soon. So if the AI can detect that like this crab is not moving for like certain period of time, they might have some another alert for us to go and check on it. So not only detecting molting, but can detect a behavior of the crab, something like that we want, right? And we can use the AI a lot more than this. In the future, we don't have to have a human to collect each crab once it's mold. Right now, from what I heard, a little bit of research with my partner, we can do the automatic lifting by using the kind of robot arm and then can process it automatically. But we're talking about a big industrial scale production, which one day we have to go that way, right? Because otherwise it cannot be a business. So I see a lot of AI opportunities. Image processing is good, but I prefer maybe AI can help me better in the future. Yeah.
We still have time for the last question, the last quick question. Anybody have that question? All right, with that, we will still have a chance to question him at the end when all the presenters are together. All right, thank you very much.
Thank you very much.
For now, Doctor.
Yeah, thank you. ครับ
Next presenter, I will have to be the one who. Oh no, sorry. Next presenter, we have a great honor to get Mr. Soihiro Yoshikawa. He's from the Marine AI Development Evolution Center, MIDEC, from Tokyo University of Marine Science and Technology, Japan. He personally fly from Japan to attend our seminar. Thank you very much. So yeah, without further ado, please welcome him. Thank you.
Thank you for your introduction. My name is Soichiro Yoshizawa from Tokyo University of Marine Science and Technology in Japan. And I will give a presentation entitled AI-driven affinity improvement of single-domain antibodies in cartilaginous fish. My presentation is not mainly AI, but it includes the immunology and fish pathology. And as you know, in aquaculture, the importance of aquaculture is really increasing now. But there are many infectious diseases happens in aquaculture, and they causes heavy economic and environmental damages. So we have some methods to prevent infectious diseases. For example, antibiotics. This is a common method to prevent bacterial infectious disease. However, they have a risk that emergence of drug-resistant bacteria, and they affect only for bacteria. And the second method is vaccine. This is a very strong method to prevent bacterial and viral diseases. However, vaccine depends on the immunity of the target fish. And target pathogens are very limited. In Japan, there are only some vaccination is released. And the third method is antibody drug. This method is very famous in human diseases. Antibody drug is high efficiency and neutralizing activity. However, very few application in aquaculture. What is the antibody? Antibody is immunoglobulin, a kind of protein. And we, vertebrate, have the immunoglobulin. From chondrichthyes, so-called cartilaginous fish, includes the shark or rays, have the ancient immunoglobulins like IgM, IgW, and IgNAR. On the other hand, we, mammals, have the IgG, IgD, and some 5 kinds of the immunoglobulins. Our immunoglobulins are consist by the light chain and heavy chain. However, IgNAR, uniquely shark and rays possess, is consisted by heavy chain only. And we focused on the IgNAR as an antibody drug because there are many advantages in IgNAR. This is IgNAR variable region that is important to bind the antigen is called VNAR and they have the low molecular weight compared with IgG that called FAB or SCFV. FAB and SCFV is very famous immunoglobulins for antibody drug, and the molecular weight is 50 kilodalton and 30 kilodalton. This is a very larger molecular weight than VNAR, 20 kilodaltons. And the artificial production is much easier in VNAR because the molecular weight is very low. And the thermostability is higher in VNAR because of the simple structure. So these advantages, we focused on the VNAR as an antibody drug for aquaculture. After the found of the IgNAR, there are many applications and research are conducted by many researchers. In human disease, there are many antibody drugs are developed, like not only these diseases, but SARS-CoV-2 and some influenza and so on. On the other hand, only one pathogens are researched in the fish diseases. VHS is a famous fish disease in the world, and our laboratory developed the VHS specific winner in 2013. But a few applications in aquaculture. So we set the goal that development and application of winners specific to fish pathogens. And today I will introduce my current studies of the production mechanisms of IGNR using sequence analysis, because the sequence analysis is a very important study for winner development. And as a second, the future perspectives of computational antibody development using AI. This is the complicated mechanism of the IGNR antibody production. After we, not only shark, but we got some infections or the toxins into our body, the antigen specific, the virus, bacteria, or toxin specific antibodies are produced in our body. And so in this study, we used the shark for using shark in our laboratory. This shark is a banded hound shark that is very famous in Japan in aquarium. And these fish are available from fishermen in Japan. And the right picture is the internal organs in the banded hound shark. And interestingly, the unique antibody production mechanism is in the banded hound shark, not only secondary lymphoid organ, that is the most important antibody production organ. So at first, we immunized, injected the antigen derived from the Edwardsella piscida. That is the most important fish pathogens that causes Edwardsellosis. So we injected every 4 weeks, and so 0 weeks, 4 weeks, 8 weeks, and 12 weeks. At the 12 weeks, we collected the organ from sharks, and we sequenced the winner sequence. This is the antibody titer of the after injection of GAPDH. After 12 weeks, the antibody titer is the highest. This shows the antigen-specific IGNR is produced in the shark. And this is the amino acid sequence of winner we obtained. Please look at CDR3 in the the right yellow boxes. The dot shows the same amino acid, but in CDR3, the variety of amino acid is seen in the CDR3. If the CDR3 sequence is different, the structure, 3D structure of winner is very different, like this. type 1, type 2, type 3, type 4. These types are different binding ability. And this figure shows the CDR3 length distribution. The yellow one is non-immunized, the healthy fish, and purple is the immunized, injected shark. The CDR3 length is varied and longer after immunization. And after immunization, the variable CDR3 are produced in shark bodies. This is the type of the VNR. From this figure, we can see the different type construction compared with non-immunized and immunized fish. So from this picture, the different structure of VNR is produced in shark. And this is the shared VNRs, the same common VNRs between the two organs. In non-immunized fish, only 3, the epigonal organ, liver, pancreas, are red. This red shows the high number of shared VNRs. However, in immunized fish, the number of the shared VNRs are increased, and epigonal organ and kidney, epigonal organ and spleen and kidney are increased. So from this figure, we found that different VNRs were produced in each organs after immunization. So from our study, VNR diversity in each organ was different between non-immunized and immunized fish. And we obtained a large number of VNR sequences with high diversity. So next step, we have to screen the antigen-specific antibody and develop AI model that can predict antigen-specific VNR. To obtain antigen-specific VNR, antigen-specific antibody, we have 2 methods. The first is conventional methods that using the experimental methods. But this conventional method is well studied, and most of researchers using this method. And the second is AI, using AI method. This method using computers to predict antibody structures and predict of binding ability of antibody. Why we use the AI to develop antibody? Because immunization and experimental screening takes a high cost and time for one target antigen. As I described, in shark, immunization time is for 12 weeks, or almost 3 months for one target antigen. And we need a large amount of water and labor for keeping sharks. And the screening method is also takes several months. So computational screening using AI accelerate developing antigen-specific antibody. And computational screening and designing antigen-specific antibody is one of the competitive field of AI research, especially in human disease. I will introduce some examples that I try to use and development for antigen-specific antibody. The first is structure-based method. One of the famous and popular AI that predict the antibody structure is AlphaFold. This is developed by Google DeepMind. And last year, the developer in the Google DeepMind were prized the developers got Nobel Prize last year. And now we can use the AlphaFold 3 in the web server. Maybe you can see the, when you have time, please search the AlphaFold 3 and you can see the server. And this AlphaFold 3 can predict antigen antibody binding affinity, like this figure. This is the structure of the antibodies and antigens. This AlphaFold 3 can predict the place of the antibody and antigen, and this shows the good binding affinity. And the second method is the sequence generation method. Some researchers using the sequence generation model using the long short-term memory, LSTM network. LSTM is a kind of a recurrent neural network, and using the Wiener sequence obtained from the immunized fish, the LSTM model trained by using the Wiener sequence, and after training, the model generate the high affinity sequence, like a language model. And after we obtain the high affinity sequence, the validation is needed. So now I introduced some research and AI, and now we screen the antigen-specific winners by experimental screening targeting Edwards-Losses. And I test AI model that can predict the structures of binding affinity and winner sequences. And the AI makes it possible to develop antibody drug for aquaculture. And I'm now master's second grade, and I'm going to PhD course, and I'm going to develop a novel antibody drug and AI model in PhD course. These researches are supported by following people and following grants. Thank you for your kind attention.
Thank you very much. It's very interesting. I also invite a question from the audience online. Do you have any question, any comment from the audience on site? Maybe start from me. Where I know that now that you use AI to predict this antibody, and also new ways to see whether the experiment will be success or not success. So it is cheap and quick, right? But I do not understand one point: why shark? Why cartilaginous fish?
Yes.
Thank you.
Thank you very much. The sharks is uniquely possess the antibody that can easily produce and artificially that can be artificially produced and easily to keep for aquaculture, because some drugs have to be kept in the minus 20 degrees and low temperature. But shark antibody is a simple structure, so the thermostability is very high. So we don't have to keep in minus 20, and we can keep in the room temperature and or outside. So it is very easy to use for aquaculture.
Sorry, it means that the knowing or the antibody from the shark experiment
Yes.
can be used to other fishes.
Sorry.
It means that when you get the antibody from shark,
Yes.
right, for the experiment, it is easy to keep the antibody, right? But can you apply antibody in sharks to other fish?
Yes. We can use antibodies from sharks as a medicine for other fish, for protect fish disease. Yes.
So about the operational time for you comparing between using traditional method
Yes.
and the AI application, right? So you said that traditional method can spend 3 months.
Yes.
And how about the AI application? That how long for using it?
Yeah, it depends on the AI model, but some success team, there are some teams that success to develop the antibody is just take the for 6 months to first the prediction and experimental validation and release setting for as an antibody drug for human disease. So, by the experimental methods, it takes much more times are needed.
Any other question from the audience? So I think with that, maybe we can come back to other general question later. Thank you very much for your presentation.
Thank you very much.
All right, next presenter, I will be the one who invite the presenter, because the presenter is our MC. Now, may I invite Assistant Professor Dr. Rungparit Chongcharoensuk, the lecturer from the Department of Aquaculture, Faculty of Fishery Kasetsart, University Thailand, to present his topic about using AI and UAV to access the fish weight of red tilapia in river cages culture. Yeah. If you're ready, please.
Hello, hi, afternoon again. My name is Rungparit Chongcharoensuk. I've already introduced myself to be an MC. So today I would like to present just briefly about some of my team research using drone and fish weight estimation. Actually, this research that I would like to use this opportunity to say thank yous to my supervisor, two supervisors actually. This research, the general ideas and hypotheses for this research that come from Professor Vala. This is the first that give an idea for using this research. And the second very important, my teachers, the second teacher is Dr. Sukrit. Dr. Sukrit, he is like the supervisor teaching me flying or flying a drone, because he got a lot of experience and expert about flying a drone, because he already already deep down on the waters and have a lot of accident using a drone. That's why it can teach me a lot for using a drone. It's very, this too is very original for using this research. So my research that we know about the red tilapia is very important species. Some we call nindang, or sometimes we call taptim, right? So the one of very important tasks, like in this, right? The thing is, we always would like to know about the weight. But the problem thing is that it's very time consuming. And in this right, you will see that approximately 4 workers, actually 4 of my teams, 1 woman and 3 men that process about the weight estimation. They got about 20 minutes per case using 4 persons, just 1 case, 20 minutes at least. 20 fish, 20 minutes, just 1 case. So this is very time consuming. And a little bit some serious problems if the fish serious injury is some fish gonna die after that take the samples. So from about these problems, we try to develop. We start with actually image processing and image analysis. If we got back maybe since 2011, this is actually from the research from the Japan, my laboratory in Hokkaido University that using this study like a linear measurements, and then Ansomdale and Zhang study about the machine learning first. The researchers always start with machine learning for the first. Then for the advanced technology, many researchers try to improve more and more about techniques. From machine learning, actually we start with image processing. Image processing, image analysis, come to machine learning and come to deep learning and hybrid deep learning algorithm for now. So for the first hybrid deep learning that start with actually from the medical sections, like in the medical field, like X-ray COVID-19 or diagnose some disease in humans, we always use deep learnings because we got a lot of images, like X-ray films or like inside our body images that we can train a lot of data, train a lot of the database, so can easily to produce about the data. So then the researchers start with the medical field, right? Then develop more and more to the agricultural field here. And anyway, that everything that I told you before, one thing is very got problem is the image acquisitions. Can you imagine that? Every research may be using the image from telescope, single cameras or underwater cameras. So the question is if you can see, sorry. Okay, I will using my finger. If you can see this is a real situation, right? This is a farm, the fish, red tilapia fish farm that contain 230 cases per farm. If my question is, if we would like to know the weight of the fish that every case inside that farm, approximately 200 cases, how long we have to spend the time for take a lot of samples? Is maybe you have to spend 3 days, 4 days, or 5 days just knowing about the accuracy, the fish weight for that farm. That's why this is really important, and this is a very problem to. We have to do something. We have to develop more something about the image acquisition, and we choose about the drone because it's easy access and it's applicable and available to using it in Thailand for now. And in the sea or the mental ray, This is the first experiments, first research that previous group. Then we developed more to the first publication in 2023. We got first publication about the drone. For that, like I told you before, this is the white drone is the drone Dr. Sukrit drones. Actually, I borrow him and fly in the Kanchanaburi, and this is very inspiring me. If we would like to know about the drone, we have to know the three things is very important. What time you should use your drone? That's the first question. Mornings, afternoons, or evenings. And the second aspect that you have to understand is the optimal time of the day. First thing is the height or the flight altitude that Ajahn Vara told you before. 3 meters, 4 meters, 5 meters, 7 meters, 8 meters, or 10s, or 20s, or 100s. Why? You have to have the questions. Why you do this? Why you do that? What is the reason, and what is the answer for taking that? For the second thing is the optimal time of the day. The third thing is how to analyze the image. And for the third thing is we have the result about the 7 meters. 3.5 to 7 meters is going to be okay for using the drone, not disturb about the fish behavior, because if you fly the drone nearly the water, one thing that's always occur is the fish change the behaviors. They avoid and they gain more accelerate swimming in the case. And if you use the highest drones, it means your image quality is going down. So about the time of the day, the answer is the morning, because the fish float up to the water because they're waiting for the first meal. And we can cut down the effect of the sun glare that can disturb about our images. That's why we have to fly the drone every mornings. So that's a suggestion. For that time, we already have the result. The result is very good, 93% the accuracy, but the 93% that we have to take a lot of time to doing this, because this is just image analysis. There is not machine learning yet, there is not deep learning algorithm yet, it's just image analysis. Like we use a Photoshop, and then we crop about the fish, we study about the pixel area on the fish and the where, then they generate an equations. You have to take a drone, and then you come back to your office, you crop, you using your image, you crop the fish like this, and you input the equations. It's okay, it's very good, but it's slow. That's why we develop more and more. We try to use other things that can help us to improve the time, operation time. And for this, we continue to study, develop more and more to become this research. So this research actually that continue with the previous research that Dr. Vara told you before about using the drone and deep learning algorithms. For the detail is EdgeCache, that we correct the data. And like I told you before, EdgeCache, we sampling the fish weight before we fly, we correct the water quality before we fly. One day before we image acquisition, we already get the sample about the weight, about the water quality, and then we fly the drone and take an image. And this is a previous model of our laboratory, DJI Air 2S, because this is like an easy access to, you can buy a drone. Okay, and the weight is approximately 0.6 kilogram. One thing you have to consider about the flight duration time. You see in my slide, the flight duration time is 34 minutes. But if you want to do that, you're gonna have just about 20 minutes. It's just okay. You please come back if past 20 minutes, because if you waiting for nearly your battery run off, your drone maybe never come back again. Like Dr. Sukrit confront this problem before. Never come back again, and they flown go down to somewhere else. Please consider, because in Thailand we very hot climate, and the battery of the drone it run out very quickly. Okay, because the spec of the drone is mentioned about 34 minutes you can fly, but trust me, in my experience 20 minutes should be okay. You have to come back. Okay, so This is our example image. We got that image and we cut down to snap to cut down the peripheral distraction, then do input to the Google Colab Google Drive using Google Colab Python coding library, Python coding to give an answer and results. So for this work, we compare between two things. The first, we use hybrid. Hybrid is mean hybrid deep learning algorithm and machine learning algorithms. Deep learning, we use computational neural networks, or we call CNNs. And for the machine learning, we use extreme gradient boosting, or we call XGBoost. Another machine learning algorithm, we use hybrid tree. Hybrid tree is mean one deep learning and two machine learning. One deep learning is still the same, CNNs, and two machine learning is XGBoost and random forest. Like it's the same ensemble model, but it's like superpower each other. Random forest plus random forest can be the XGBoost, something like that. So we test and tuning about the training circles, epochs, and estimator, and random state. That depends on the model you choose. First thing you have to understand, you have to read a lot about the model that you select for using in deep learning or machine learning algorithms, because we have a ton of the algorithm that we have to choose. We have to understand that when we have to use that one, when we have to use those one, we have to understand the theory. We have to pick directly to our task for using the machine learning or deep learning algorithm in such case. So this is a result. After we flown the drone for nine times, and we got the data for 9 fish weight class. Then the total image just about 3,600 images. One thing we have to make sure, if you would like to do the research in this field, you have to make sure that the water quality, because we are aquaculture, right? You have to confirm that water quality, it doesn't have any effect on your fish behavior. You have to check every detail, especially DO, temps, total ammonia, nitrogen, or nitrites. You have to check before you do further about image analysis. Except you would like to study about the effect of some things, or effect of ammonia, effect of nitrite on the fish behavior. It's okay if you would like to do like that. Okay. And this is the result. So the reason that Professor Vala told you that the accuracy is equal 76%, but for this time we can improve the percentage of accuracy, because we, like I told you, we add on about the machine learning, another machine learning to help one machine learning to become two machine learning, to the whole deep learning to improve the accuracy, improve the circles of learning, improve the epochs. That's why we gonna have a better result. 4.3% that better. Anyways, the result is good, but the time consuming is a little bit decreased. That because we input more complexity about the model. That is mean our laptop is spend more time for process. Anyway, if we consider about the time, it's just 12.85%. It's just about 0.27 seconds per image. For me, is accepted. If we consider about the percentage of the accuracy, 4% with just about 0.20 seconds is really a little bit. For me, it's accept. So this is example from the result. This should show in every research that you publish about the confusion metric when using the image analysis, that can show you that is it stable, yes or not? What is the accuracy from every class when you're using about your model? This is very important thing you have to show in every research about this field. So about the result and discussion, the reason why tree hybrid algorithm can perform better, this is a reason. The 4 reasons that possible, because we input about the random forest that integrate ensemble energy like extreme gradient descent that can like a superpower each other to enhance the percentage of accuracy. So in sample synergy, we can increase fine-tuning optimization and adaptability to the variant that also can help a lot from this. So about the recommendation and insight, like a further future that we would like to go, one very important thing that we did do in the past is automatically, automatically analysis. Like we would like to have a result real time. Means if between we fly the drone or we fly the drone, we have to have the result real time. For example, if I fly the drones over one case, the result should have real time. What was the best for that time? This is a research that we will go further. And luckily, I think for now on, we have a good chance or the good opportunity to get some grant to continue this research. I think maybe we have the good news for continue this research, but not sure yet, but I think we have a good news for now. So I think this is for today. And another thing is image extraction. If we can find or we can do like a automatically extraction, is possibly can improve the accuracy. And luckily, we also have that code for automatically extraction for now. So, so thank you for your attention.
Very much. Thank you very much for your great presentation. I learned a lot. Is there any question or comment from the floor? เชิญครับ
Thank you, Doctor. Would like to know in the different level of the DO, how we can adjust all the criteria for the DO level before you use the drone. Because if the low level of the DO, the big fish will need to oxygen in the top of the water. And some of the river is DO high. The same small, middle, and large fish will on the top. How in your research, how the DO you use for the criteria?
Okay,
thank you.
for my research, the DO that I use for the criteria is more than 5 or more than 3. That is standard. But from your question, if the DO different from somewhere, how can we generate or do the AI for the weight estimation? My question is if we don't have any data enough to covering around area or any situations in this system, we have to change. We're gonna have to change like from big data analysis to precision aquaculture. Precision is mean that precise from everywhere using their own data. Because I think for generate this model, one big advantage for using AI is the data. It means, for example, if I change the species of the red tilapia, I use the company one, and then I move to the company two. The body weight with the weight is different. Yeah. That is mean my equation that come from the first company and it doesn't work from the second company. That's why we have to collect more data analysis. We have to collect more and more and more. And also the disproportion maybe for the 3 milligram per liters, the feed come float some type, and for the 4 or 5 or 6, that second and third and fourth type that come from. If we can covering around the years and covering about any situation, the data set is so huge that why we can find an average or we can use properly model to evaluate that things. But if we can did access or cannot access for that, I suggest we have to start with the precision aquaculture. Precision in this case, it means using our own data, precise our own tasks that can give us our own answer for the first.
Yeah, thank you. One question: how you can tell us for the if the DO lower or higher, such as the 5 ppm
Yes.
and 4 ppm and 3 ppm,
Yes.
how the accuracy
Mm.
drop.
Luckily for me, in the Kanchanaburi province, this soap oxygen is quite still the same. Because if sometimes it's not still the same, it means like the high turbidity is how to say that น้ำบ่าครับที่จังหวัดที่เขื่อนปล่อยน้ำมาแล้วน้ำมันแดงน้ำโค้กที่เขาว่าคือเป็นอย่างนั้นเนี่ยถ้ามันเกิดเคสนั้น in that case เนี่ยคือเราบินไม่ได้อยู่แล้วมันเป็นเคสที่ DO ต่ำครับอาจารย์ DO อาจจะ2หรือ3ซึ่งมันจะ match is merged with the image analysis that is mean the part of the DO so decrease the image not คือเรามองไม่เห็นอยู่แล้วครับพี่เวลาช่วงจังหวะที่น้ำไม่ดีมันมาพร้อมกับช่วงจังหวะที่ถ่ายภาพไม่ได้นี่คือจุดที่มันเกิดขึ้นเช่นไอ้ช่วงน้ำโค้กที่เขาบอกน้ำโค้กปลาตายหรือฝนตกเนี่ยเราก็ขึ้นไม่ได้เราก็ถ่ายไม่ได้คือมันจะไม่สามารถเป็นช่วงที่เรา analyze ไม่ได้พอดีมันก็เลยไม่มีคำตอบให้พี่ว่าขึ้นมากขึ้นน้อยต่างกันไหมเพราะว่าคือถ้ามันแย่เมื่อไหร่เนี่ยคือโดยมากเราจะมองไม่เห็นมันก็จะแทบ analyze ไม่ได้นี่คือจุดอ่อนมากๆอีกหนึ่งเรื่องครับ
Thank you very much.
ครับครับ
Thank you very much. I guess we have time for one short question. Another short question. Do you have? All right. With that, let's keep the question for to the end of the this seminar. Thank you very much, Dr. Rumparit, for your great presentation. Okay, next we have a presenter from China, Professor Yun Tao Wang. Yeah, he's already there. Thank you very much, Professor, to be with us.
Hello, hi, man. Hello, everybody.
Hi, thank you very much. Professor Yun Tao Wang, he's from the Second Institute of Oceanography, Ministry of Natural Resource, China. He will come. He's honored us today to present about the Monitor project, a very cool name, mitigation of natural incidents toward ocean resilience monitor using satellite and couple physical biogeochemical model with the AI application. Professor, if you are ready, thank you very much. You may start.
Okay, so thank you, man. Thank you for invitation, and it's a great honor to be here and share some of our program, in specifically for the UN Ocean Decade endorsed Monitor program, and also to fit in this seminar, I have added some components regarding the satellite observation and also the AI applications. So my name is Yun Tao Wang. I'm from the Second Institute of Oceanography that's located in Hangzhou, China. And as you may know, the UN Ocean Decade was initially promoted and implemented by the UN 2030 Agenda for Sustainable Development. And the two sections of UN General Assemblies announced the 2021 to 2030 will be United Nations Decade of Ocean Science for Sustainable Development. And we really call it as Ocean Decade. And there are three objectives for the Ocean Decade to identify the knowledge and for sustainable development, generate knowledge and understanding of the ocean, and increase the use of ocean knowledge. And ideally, we hope to, based on the science we need to achieve the ocean we want. And there are 7 goals that have been identified: an accessible ocean, a predicted ocean, a clean ocean, a healthy, safe, productive, and inspiring oceans. So these are very high level outcomes, and we hope we can achieve them by the end of 2030. And if you look at the organizational framework for the UN Ocean Decade, under the IOC Executive Secretary, we have the Decade Coordination Unit, and there are 2 advisory boards, one called Decade Advisory Board, and the other one called Strategy Communication Group. And for each of the groups, we have about 15 advisory sitting in the board. And the UN Ocean Decade has been componented into 3 major parts: the program that is global scale, large scale for important issues, and also project and activity. So the project is more regional oriented for specific question, and similarly for activity is like for conference or seminar that is an event. So lastly, we also have the opportunity to have donation if you want to support the decade. So during the past 5 years, especially for China, there has been about 6 programs that have been endorsed in total of the global 57. And for project, in total, there are 472 projects, and 13 of them are leading by China. Here is a list of all the program and most of the projects. And you can see one of them is leading by myself. It's called Mitigation of Natural Incidents Towards Ocean Resilience. And we call it in short as the Monitor Project. So the Monitor Project was initially kicked off in September 24 in Qingdao, China. So during that kickoff, we invited our director and vice director, and also the vice president of IOC and the president of IOC Africa, and among other professors to join for this event. So why do we want to do monitor? So because there are a lot of threats that have been identified in the coastal regions. So due to the climate change, the ocean acidification and warming are very prominent. It introduced like eutrophication in many of the coastal regions. And at the same time, it will drive for extreme event like the severe sandstorm, super typhoon, or marine heat waves. All these events will have an impact to the ecological ecosystems. We will identify like coral bleaching, harmful algal bloom, and our system is approaching the tipping point in a rapid ways. For example, there are some common environmental problems like the hypoxia. It has been identified in many of the coastal regions, in China and also in Thailand. So the area is expanding and the oxygen level is declining. If you take a look of the tendency, you will see it is not stopping. So the trend is more severe in many of the coastal areas. And you can see the background, there's no color in Gulf of Thailand or China, not because the situation is getting better, but because we are lacking of data. So for the global observations, like you will see the drifter trajectories, they are mostly concentrated in the boundary current. And for many of the coastal regions, we don't have a sustainable and easy management observational asset that can run for a long time and to support our data acquisitions. And without data, we can hardly to develop regional ocean models to facilitate for marine ecosystem health. So these are the regions that most of the operational forecasting system are covering. You will see most of the forecasting system are concentrated in the global north. But for the global south, we barely have any of the operational forecasting system for marine ecosystem. But the global issues are impacting for all of us. If we divided them like the climate change related issues like warming, precipitation, sea level rise, they are happening almost everywhere. And for the non-climate related issues, overfishing, eutrophication, oil spill, these are also happened in many of the developing countries. So it is crucial for us to develop sustainable observational system and to make reliable forecasting for future perspective. So the first part we need to do is increasing the observational systems. So like currently we have been using a lot of different technologies from satellite to Argo, BGC Argo, and underwater glider or sail drone. So these are important assets that can help us to observe for the ocean data. And we can deploy them into a comprehensive network that working together to have a 3-dimensional data set. So from the deep ocean all the way to the surface. So for example, in our lab, we have been developing a system called Ocean Color Remote Sensing cycle system. So this is like you can see in the movie here, it's like a sphere, and you project different satellite data onto the sphere. So you can pick up the region and what kind of scientific question you are focusing on, and then make the analysis. And also for the global BGC Argo deployment, these are important for us to have the vertical observations to the system. And during the past 2 decades, there have been about 400 BGC Argo being deployed in the global ocean. And so in China, a large effort has been made in the Northwest Pacific and the North Indian Oceans. And with a collaborator with friends from Tunis and Egypt, we are also trying to deploy more Argos in the Mediterranean seas. But for the South China Sea and Gulf of Thailand, because of the shallow water depths, it is hard to deploy the Argos. So the Argo are very useful to depict some of the important events. For example, there are some typhoon passing through the Northwest Pacific. And before we only have a satellite, and there are a lot of missing in the data set. But with the Argo, we have 4 depth observations, as you can see here. We can measure from all the way from the surface to the deep ocean. Then we can have a better understanding about the impact of the typhoon to the entire water column instead of only the surface. So we have been recognized the importance for observations. And there's one important conference every 10 years called Ocean Ops meeting. So the next meeting will in China in 2029. And so during the past, we have 3 ones. The first one was in France, the second one in Italy, and the third one in US. And then we are going to have the 4th one in China. So these are the important platforms that help us to identify the way to develop and for the data. And after we acquisite all the data set, we need to use the data in a more comprehensive manner. For example, we can use the data for numerical models. So we can identify the marine ecosystem features and divide the global ocean into different parts. And we can develop the model that is similar with our so that is similar like the real ecosystem, the nutrients, phytoplankton, zooplankton, and detritus. And this is the model we are using now. And we merge all the observational data into the numerical model. And we can use the model to make near real-time forecast to the marine ecosystem that will help for the ecosystem health. And all the data, we hope to have more interaction and to use the data, have a prediction for what will happen in the future. And then we come up with a new technology called the digital twin of the ocean. So it looks like a visual intelligent platform that is interdisciplinary modeling, impression, and platform, combine data from model and observation, and to analysis expression for the land coastal system. And 2 years ago, we have the DITO Summit in Xiamen, and about 500 people from the global world participated in this event. So one of the application is we can develop the operational forecasting in the coastal areas. So we can use observation to develop a numerical model to forecast for primary production and nutrients. That is important and can be the guideline for aquaculture and also for fishermen. And so in the coast of South China Sea, we have been developed the coupled physical and dynamical models. So you will see the model, the mesoscale eddies can transport chlorophyll and nutrients into the interior of South China Sea. And you can also see the impact of the open ocean to the Gulf of Thailand. What's their impact in the coastal areas. And we hope to produce more useful product like the temperature, chlorophyll, nutrient, oxygen that is useful to the coastal community in all around the globe. Like the oxygen, how will the oxygen change during the extreme event like typhoon? So that will be helpful for the fishermen and aquaculture to protect their product from extreme event. And there's another UN Ocean Decade project called Coastal SOS that is also focusing on the coastal areas with the digital twin ocean technology. So similarly, like the Xiamen Bay, we acquire all the data from the sky, air, land, and the sea, and merge all this data into the numerical model. So it can near real time predict what will be the dynamic change and what's their impact to ecosystem. So here is a movie that shows the system we have been developed. So it's like a digital twin of the ocean. And you can see the coastal community, and this is the observation we have. And if you take a look of that, you can see how is the tidal gauge and what is the direction of the wind. And if you want to have some different scenarios, you can choose from the top panels, like inundation. Then you can zoom in to the coastal areas. If there's a tropical cyclone, which areas will be inundated and which part will be safe. So this system will be helpful for the coastal community to make wise decisions and to protect the people and the industrial for sustainable marine ecosystem. So this is a collaborative map for the monitor project. Now we are mostly focusing on the African and Asian areas, and these are the coastal areas we have been focusing on and hope to have a more realistic forecasting for these regions. In the past 2 years after the implementation of Monitor project, we have been successfully organized many global events and encouraged global engagement for marine ecosystem health. For example, like the Global Ocean Summit and also the Sino-US Joint Scientific Expert Group meetings. And every year we provide training and education opportunity for the young generations. And about 10 training courses will be offered to the developing countries. And also, we encourage high-level discussions like the Ocean Conference in Barcelona. And we hosted a satellite event during the UN Ocean Decade Conference. And I was very glad last year in April, I was in Bangkok and also hosted a Monitor project event during the Westpac meetings. So with all this effort, we hope we can work together with the UN Ocean Decade Monitor project and with your help to foster a more healthy marine ecosystem in the coast of China and also Thailand. So with all that, I'd like to thank you and hope we can have a blueprint for the Monitor and help to protect our ocean. Thank you very much.
Well, thank you very much, Professor Yuntao, for your great presentation. I can see a lot of data.
Thank you. Sure.
I see a lot of data. I think so. We discussed this morning. We were always talk about lack of data, but you show us a lot of data. Maybe there should be a bridge between AI for fisheries with this data. So at least we fulfill part of the data requirement. Maybe the what I feel is like we don't sometimes if we don't have actual measurement data, we can use model data. Right? All right.
Yeah.
Thank you very much. Is there any question from the floor? Yeah. So without that, I think I will keep the question toward the end. Professor Yuntao, please still stay with us. Let's us move to the อาจารย์วรามีคำถามนะครับ Okay, so with that, may I move to the last part of the today's seminar? May I invite every presenter to sit on the bench, and we now can invite the question again for the second round to everybody that can present. Okay, so actually this morning there was a question to Dr. Sukrit. This one.
The question is that, dear Ajahn, thank you for interesting talk. Do we able to apply the technology with underwater video, especially monitor the status of the molding in the real time with combined technology of AI and digital twins?
The question asks about the underwater camera video. Basically, when we do the molting in crabs, we keep the water level very low. Just enough to cover the shells of the crab is enough. So we usually not put them in the very deep water. So taking the video under the water might not be very cost effective and might be putting too much on the technical difficulties. So basically, we decide that taking picture from the top view would be enough. So underwater would be very difficult for us to do. So yeah, I don't realize any softshell crab productions that keep the animals in the deep water. Yeah.
Thank you. So now I think we don't have any other question from the audience online. Is there any question or comments to our presenter today? Or you may have question to each other. Let's spend like 5-10 minutes for this one. Okay, so I have question actually. Actually, my question might be too general, but maybe can you enlighten me? What is the difference between deep learning and machine learning? I think both you because you guys are at the field and you keep talking about deep learning and machine learning. Yeah, maybe you can explain a little bit. Thank you.
Yeah, thank you. It's a machine learning. Okay. Machine learning, like I told you before, or the audience before, is based on machine process. In general, machine process is computer. It's a computer and use a model that created before. That's a machine learning. Uses many models. And the deep learning is developed from neural network. Neural network is one of the machine learning that have only one hidden layer. But whenever you use the hidden layer more than one layer, it means it's deep learning. It's more complicated and advanced and similar to human brain process.
Okay, Shim, we have another question from the online audience. So
Okay, Ajahn, I have a question for Ajahn Wara. Is it okay? Is my voice audible?
Yes, your voice is perfect.
Okay.
Please proceed with your question.
Okay, thank you very much for valuable insight, Ajahn. Ajahn Wara is a maybe I already mentioned in the question column that I already explained about my case. Okay, I have a question about is it possible if we create some device to predict case like upwelling or rising sulfur from like above, from the bottom of lake, Ajahn? Is it possible? Because I'm a master student in Kasetsat, and I have a lot of experience with the study in upwelling case in some lake in Indonesia. Maybe I need your suggestion. I don't know if AI approach would be some of the technological approach to solve this problem. I hope. Thank you very much for Ajahn Wara for your suggestion.
สรุปมา
upwelling น้ำขุ่นเดี๋ยวอาจารย์ยุนเฉาน่าจะตอบได้
I think in my opinion is possible if you want to predict upwelling. It means you have to monitor the water quality that relates
Yes,
to
correct.
upwelling. Whenever you know what the main effect of upwelling, you can use a deep learning or machine learning to learn, and you can predict. I am quite sure you can do it.
Yeah. So I guess I can may add a little bit on that. Usually to predict, I'm a physical oceanographer, to predict the behavior, the movement of the water. If you have enough measurement, you can understand the trend. You can understand the relationship, and maybe you can also provide the prediction or the early warning. Professor Yun Tao, do you have any advice or any comment on this?
Yes, I think that's a very good question. So because of the ocean, the dynamic, actually, we generally have a good understanding about what is the driver, what is the result. In terms of upwelling, so it is driven by some specific dynamics. So in the coastal regions, usually it's like the wind. So the wind will drive the offshore Ekman transport, and then we will have the coastal upwelling. And then if we have a good measurement for the wind, we can calculate the wind stress and make a good prediction for the upwelling and coastal dynamics. So similarly, in our models, we have a different parameter that they are interaction with each other, but some of the factors are ahead of the others. So we can use those index as an indicator to make good predictions.
Right. Thank you very much. Thank you. So I heard about two terms that I like very much. Now it is the bridging between numerical model, a real understanding of the physical process, and also ability of AI to understand the pattern and predict that one. So in order for you to predict and warn about this upwelling that cause a bad effect to the fisheries, you need numerical model, you need basic understanding, and you need good measurement. If you have all of that, I think AI can also do the prediction.
Okay, Chan. Thank you. Honestly, thank you very much for all the valuable insight. I mean, it's not just about the water quality, but also the physical wind and effect of a wind is also have a effect, give it effect to upwelling incidents, right?
Yeah, I guess. Yeah, as a physical oceanographer, the upwelling mainly caused by wind.
Yeah.
If you have a good data of the wind, like Professor Yun Tao said, maybe you can predict the upwelling. But of course, sometimes you don't have a good prediction of the wind. You can use AI to predict wind, and AI that prediction can give you a warning about the upwelling and the problem of the fisheries.
Okay, one question, Ajahn. Is it possible if we put some sensor, something like sensor in deep on a lake, and they measure real time of dissolved oxygens? Maybe is it possible? And they can give it information to us, and we can monitor every day the dynamical of dissolved oxygen. So from that data, we can collect it, and if there are some I don't know, maybe the data change, we can predict that it will be possible if the upwelling will be coming, something like that.
Sure. So I guess Professor Yun Tao, would you like to add to this?
Yes, so thank you. I think that's a very good question. So the reason why we do the forecasting is we want to have some knowledge in advance of the event. So like upwelling, like oxygen, hypoxia. So currently, the reason why we deploy a monitor project is we want to have a good observation for data and to develop for numerical model for forecasting system that will help the local stakeholders, fishermen, aquaculture, to make good prediction that can help them to make decision beforehand. So like for the oxygen, if there is a upwelling, it may relax and have more oxygen being supplied. Otherwise, if there's a typhoon, it may reduce the stability of the cage for the aquaculture. And with the model, we hope to predict the trajectory of typhoon. And so the aquaculture, they can, like in China, the aquaculture, they will move their cage like from the South China to the north, so that will not be impacted by the typhoon, not under the trajectory for typhoon, and that will be safer for their fish. So similarly, like the soft shell crab, yeah, if we have a typhoon, it will definitely do damage to the aquaculture. But if you know the typhoon is coming in next 2 days, then you can do some action and predict your aquaculture farm, and you can like build into put them into a building that is more resilience to typhoon and make it more safer. So that's the reason why we want to do the model. And currently, also for the digital twin technology, you can make some prediction by yourself. Like you can add a typhoon, what is the trajectory, what will be the impact, and then the next time when it really happens, you can make your decision in a wide and scientific manner and make a good decision.
Okay. Okay, thank you very much, Ajahn.
Yeah, there are a few questions from the audience online.
So the next question may be to Dr. Vala again. So the question is, have there been any successful commercial application of AI-based fish measurement technologies in aquaculture in Thailand? What were the key factors influencing their adoption by farmers?
The results show from the in the morning presentation from the algebra, they use the AI or machine learning to predict to count the number of animal. That show the result of based on the research. And the key factor to success or accuracy, it depends on the data or image they can collect and let the model to learn. Whenever they have enough data, they actually come from the good result. Okay. That's okay. Thank you.
Okay, thank you. Another question is to Mr. Yoshizawa. It is very thoughtful presentation, a part of the extreme stability of IgVNAR antibody. What are other advantages could this antibody provide? For example, do we have any data showing that shark antibody could provoke a weaker immune response, lower immunogenicity compared to other alternatives? Sorry.
Thank you very much for the questions. First is the disadvantages of the original.
What are the advantages could this antibody from the shark provide?
Sorry. Okay. I got it. The advantages of the IGNR of the sharks is mainly 3 points. The first is the that I described, the thermostability. The antibodies can stand for the high temperature. And the second is the easy production. Generally, the antibody production costs is very much. So we have to decrease the cost to sell. For IGNR is the very simple structure and small, so it's easy to artificially produce. And the third is the third is unique binding activity. The part of the most important part of antibody is the CDR3. This part is depending on the length of the each antibody, and CDR3 of sharks is very long, so very longer than other antibodies. So IGNR has a unique antibody, unique binding ability compared with the other antibody. Thank you. And other.
All right. There is
yes.
maybe there is other small
Other.
sub question.
Yes.
He asks, do we have any data showing that sharks antibody could provoke weaker immune response compared to other alternative?
Sorry, I have no idea.
All right. Thank you. Thank you very much. Any other question? I have question maybe to Dr. Rumparit and to everybody, because I'm not the researcher in that field. You were also talking a part of deep learning and machine learning. You were talking about different algorithm. I mean, very complicated name, lots of complicated name. And Dr. Rumparit said that choosing algorithm is very important. This and this and this, or maybe you have to add many algorithms to increase. My question is that, do we have enough algorithm or good algorithm enough for the fisheries? Or should we try to build the new one for our fisheries? Because you said, and since the morning, that AI and fisheries is like a new things. Thank you.
Every day, many researchers develop new model. To actually, they want to get the high accuracy and they show the result. Maybe yesterday, some research show the accuracy is 99%. Today, the other researcher show 99.9 or 0.1%. Okay, because each model they can fine tune, they can develop. It's based on computer, so you can change or you can put something inside the model, so everything change. And maybe you can also, if you create a model, a new model, you can say these are your name model, something like that. So finally, they get the highest accuracy in that kind of the task. That is for this field, I mean. And you see for the image classification, they have the website. I forget the name. Maybe ImageNet, something like that. Every year they let many companies or person to competitive to predict the image in website and show which company, which one can get the high end, they can get the reward, something like that. Mhm.
So for me is I suggest the researcher that we have to adapt ourselves for every day. We have to improve our skill. We have to read a lot, and we have to focus on the thing that what we have to do. For example, if you would like to go to EPA analysis, you have to how to say that you always have to update yourself by reading papers or review articles or something like, and improve your skill. And you have to that I told you before, you have to understand about the group of the deep learnings or machine learning that can cost you a lot, because you have to choose the right one for the right job for using the model.
Thank you very much. So I guess with this answer, maybe I can summarize that there is enough algorithm, but the point is there are always not enough good data, right? So main important point is to improve the data. Some of the data can be really, can be really quality control. For example, his data, he used the data in the lab, right? But the data from farmer, the data from numerical model, or the data from everywhere else, free source, cannot be controlled. And that's bring about the bad result, not the algorithm itself, right? As of now, I guess there is no more question from the online audience. Is there any other comments, question from the floor? With that, I think we can conclude today our seminar. I will move to that podium now. All right, so ครับ โอเค อาจารย์มีคำถามนะ อาจารย์มีคำ Okay. All right. Yes, with that, thank you very much. It has been fruitful discussion, although it can be a little bit quiet and sleepy afternoon, but I hope that we did learn a lot of things. So the annual special seminar for Faculty of Fishery on AI and Fishery Research Frontier and Technology has now concluded. We hope that all participants found the discussion, the presentation is valuable. We express our deep appreciation to all of the presenters that come to share your excellent research on AI and fisheries, right? To express our appreciation, may I invite Associate Professor Dr. Wanchai Waravatanametikun to present a token of gratitude to our distinguished guest speaker. Right. So first, may I invite Associate Professor Dr. Wara Thepahudi, lecturer from the Department of Aquaculture, Faculty of Fisheries. Thank you very much. Next, Assistant Professor Dr. Sukrit Nimitgun, Department of Aquaculture, Faculty of Fishery, Faculty of Fisheries. Next, Mr. Soichiro Yoshizawa from MIDEC, Tokyo University of Marine Science and Technology, Japan. Next, Assistant Professor Dr. Rungparit Chongchareensuk, Department of Aquaculture, Faculty of Fishery, Ksesat University. Last but not least, Professor Wang Yuntao. I will meet you at the end of the month. I will carry the token of appreciation to you. Thank you very much for your participation.
Thank you.
All right. With this, I like to we can conclude the today's seminar, and we hope to see you again in our next year's seminar. Thank you very much for all of the attention and the question and presentation. Thank you. Thank you very much, Professor Yuntao. We conclude now. Thank you very much.
Thank you. See you soon.
Yeah. Professor Yuntao, please stay with us. Let's take a group photo.
Okay.
Okay.
Bye bye. Thank you.
จบแล้วนะครับขอบคุณมากครับ